All right, good morning or good afternoon, gentlemen. So our agenda today is we're going to review some percent error, and then I'm going to lead us into the new topic of precision versus accuracy, and then you will have a quiz on Monday, and your homework will be a precision versus accuracy worksheet for you to practice, and then I might make an Edpuzzle. However, that is in the air right now. Let's see how this goes. So first things first is I want to try an example as a reminder. And then you will have question two to answer. And so pause this video right now, and then I want you to go ahead and answer question 1 and 2, and then unpause it, and we'll discuss in a second. All right, so with percent error, if we're looking at number 1 right now, oh goodness, excuse me, thought I had a pen. There we go. Okay, so my question reads that you find the volume of a liquid to be 32.4 milliliters, but the actual volume is 31.0 milliliters. What is the percent error? And so my first thing I have to do is I have to determine what each variable means. And so I found this volume, and if I find something in the lab or anything, then it becomes my calculated value. And so I'm going to plug in my 32.4 in my calculated. And then I have this keyword right here of actual to tell me that my volume actually is supposed to be 31.0. And so that gets pushed in to our actual values. So we have 32.4 milliliters, 31.0 milliliters, and 31.0 milliliters. My 32.4 is going to be subtracted from my 31.0. I divide by 31.0, and I keep that entire decimal. I multiply it by 100, and I get the number of 4.52%. I end up with a long decimal where it's 4.516. Because that third decimal is greater than 5, I can round up my 1 to 2, and I round it off to 2 decimal places to get my 4.52%. Excuse me. Oh my goodness. Then I'm done. I do want to review. So there's 2 types of error, if we recall, and our type of error. So my question reads, what type of error is overestimated and what type of error is underestimated? So an overestimated, it means I have too much. And so an example is our question 1 here. 32.4 is a lot greater than 31.0. So I end up with a positive percent, like value on top. And so when I'm dividing and I multiply, I end up with a positive percent. This means that I had an overestimate because I overestimated my value. My calculated was 32.4, my actual was 31. So I had too much on this side in my calculated value, so I end up with a positive. However, if this was 21.0, let's say, and I subtracted from 31, I wouldn't have enough. So I'd end up with a negative value instead, and I'd have an underestimate because I could have had more. My measurements are very off, first off. However, this is small, and so I end up with this negative, which means I have an underestimate. Whereas if I have a positive, I'm overestimating. Positive means more, negative means less. All right, so precision versus accuracy. What's important to note about this is it's how closely you can measure versus how close you got the expected result. And so my expected result, move that up there, my measuring is my precision. And so when I'm measuring something, I want to measure how precise I got there. Whereas accuracy is wanting to know about the expected result. And so I want to know, did I make the expected result? So I have 4 little like bullseyes. So if I get all of them in the middle and I get like a lot of them in the middle, I have high accuracy and high precision because I was able to closely measure together, but I got my expected result. Here, I measured over here, and so I had very good precision, but I had low accuracy because I wanted to hit here, but I hit here. But I hit all of them here, so I had really good precision, bad accuracy. This one you would consider high accuracy because you're getting them all in this little bullseye area. You get where you want to go, however, they're scattered out. So I don't have good precision. And then here, I wanted it in the middle, and they obviously went kind of everywhere, so it's low of both. It's low accuracy and low precision. So high accuracy, high precision, low accuracy, high precision, high accuracy, low precision, and low accuracy, low precision. So here's a comic for you. It's just, how is that one? He said, then catcher goes, you're still a tad high, but you got a real nice pattern. And so his accuracy is low. He's not making it to the catcher's mitt, but his precision of going high and staying kind of in this area of the fence is very good because he's hitting in the same location. It's just that his accuracy to hit here is not as good. So good precision, not accuracy. So high precision, low accuracy. So now we're going to move into our percent differences, which this measures our precision. So precision is measurable, and so this is what we use to find the difference. And so when you're finding the difference, you're always going to have value 1 minus value 2. You're going to average our values, and then you're going to multiply by 100. To average our values, you add both of them together, and you divide by 2. And so find the difference between 1.4 grams and 1.8 grams. So I'm going to set up, I'm still turning it, aren't I? So sorry. So I'm going to set up my whiteboard. My first value is 1.4 grams. And I'm going to subtract that from my second value of 1.8 grams. I will then take 1.4 plus 1.8 to get 3.2. I'll divide that by 2 to get 1.6, and I'll put that on the bottom with my units. I take 1.4 minus 1.8 to get 0.4 negative, so I get negative 0.4 grams. I'm gonna cross that out. I then take my negative 0.4 grams and I divide it by 1.6 to get negative 0.25 times 100, and I get negative 25%, or in this case, it's fine to have just 25%, because I'm not estimating how well, I'm just finding the percent difference, and so I had 25%, because if I still switched these, I would end up with the same percent error right there. Whereas I wouldn't do that in a percent error. So my percent difference can be positive. So I had a 25% difference. Moving on, I have qualitative versus quantitative data. This is what you'll be working on in lab this week. We're doing a liver lab. And so with that, what you'll do is you're going to determine some qualitative and some quantitative data. Your qualitative data is the quality of your data. It describes the properties or characteristics. So your quality is your property or characteristics. Your quantitative involves a measurement or a quantity. So quantity, quantitative, quality, qualitative, yeah. So an example is, it's hot in here. So it's hot in here. I'm not making a measurement. I'm making an observation. It's a characteristic of the room. It's hot. So it gives me a qualitative data right there because it's the quality. The temperature is 87 degrees. There, I'm giving a quantity or a measurement, and so it's my quantity. It was a loud noise. That is another characteristic. It's describing something, and so it's a qualitative data point. The computer has a mass of 1.5 kilograms. Right there is a measurement. It's the quantity of mass of that computer to make it a quantitative measurement. And it tastes sour is a qualitative because you're giving a property of the candy. And so qualitative, quality, quantitative, quantity. Just know those cues. So now that's all I have for you. You're going to be working on the liver lab when you're in class. However, if you are in my my blue cohort, you've already done the lab. And so if you have not completed it, especially now that you've watched the notes, make sure to complete that and turn that in to me when I see you in person. You have a precision versus accuracy worksheet, and there's going to be a quiz on Monday. The quiz on Monday is going to cover the notes that we've gone through so far, and so make sure you're there, and we're going to talk about our expectations when we're doing the quiz as well. So if there's any questions, please email me. Other than that, go work on your homework and have a wonderful day. Bye.